Hello everyone, I'm Dr. Dror and welcome to my channel. Today I'm going to show you something that I came across while reviewing some open source code. I don't remember actually which package it was, but it doesn't matter because I suddenly saw some notation, some syntax in Python that I didn't know, so I decided to dive a little deeper into it and prepare a video for you so you can skip the dive in. The syntax I'm talking about is this, what you have here. And you need to notice this slash here and the star here that are really weird, and it's not very clear why they're there unless you know what they're doing there. Write some comments below if you know what I'm going to talk about. And how do you use it actually, because to be honest I'm not so sure yet about the actual use cases, but it's still there, so it's good to know. So let's jump into the code and have a look. This is the syntax we have, and we will understand slowly when and how do we use this slash here and the star here. But let's start with the very basics. Let's say we have a function that takes two positional arguments, a and b, and this is the most simple approach or simple function you can think of. That will work as we expect, right? This will work as well as we expect. Now we can swap things because we are now using the names of the variables. We can also do that, and that will work as well. However, if we will try to do this, because both are positional arguments, our Python will complain that it expects another argument, a positional argument b, and we didn't provide it, so we get a type error. Similarly, if we provide d as with its name, it will complain that, hey, I need a. So that's one thing we have. We can also define an optional, a keyword argument here with a default value, and this will work as well. And here it's a little bit more flexible, right? We can have 1, 2 like this. We can have also this way, so the 10 is assigned implicitly to C without naming C, right? And we can also name C here, and that works as well. This one won't work because we start with the keyword arguments before the positional ones, so that will break. This will break as well for the same, pretty much the same reason. And here, what do you think? So we have 1, B is provided, C is provided. It's supposed to pass, right? That's nice. So what's the motivation for this notation that we saw here at the beginning? Let's have a look at two cases, two things that motivate this definition. I linked here, this is the PEP that explains more about this. But imagine you have this function, and you want that the key argument of this function could only be provided if it's explicitly stated that the name of the variable is key and you give it some value, which is none or maybe not none. And in other words, we don't want to have this. This we want to reject, and we want to have this. And a naive way to do that or achieve this is using this implementation. So we use the star ignore, which takes all the leftovers of the positional arguments into a tuple. And if this tuple is not empty, then we raise an error and we say, okay, we got more than 2 positional arguments. That's wrong. And otherwise, we just return it. So that's a way to achieve this, but as you may say, that's a little bit cumbersome, right? And this works that way here. So 1 and b are provided, and then and nothing is provided as key, so we get the default value none. Here it will complain because the 3 is kind of picked up by the ignore, and then this tuple is not empty, so we get an error. But if we do it this way, then it passes, right? That's what we wanted. Another motivation for the notation above is conflicting options. So imagine you have this function here, and you pass it this keywords arguments, as with the double star operator. And then you want to return the name in these keywords, but this will conflict, right? Because you also have the name here. And if we try this out this way, like so, then we get an error because there are multiple values for argument name. It's given both here, but also here. So it's a bit of an override and it's not clear what's going on here. And yeah, that's that. So that's the motivation. So let's look at the solution Python provides and the syntax we have here. We have the star here in the middle, which is corresponding to this case where we want that the keywords arguments could only be provided if their name is provided. And then you have this nicer implementation and we can run it and you see that this will work and we will get that key is none because it's not provided. But this one, even my IDE complains about that. It complains that it has 3 arguments, positional arguments, but the third one is not supposed to be there. It can either be with a name or not given at all. So if we do it this way, we provide the name, then it works. Then we can have also the slash, and the slash says that everything before the slash is only positional. After the star is only keywords argument, and in the middle you may have a mix. And this is how it looks like if we evaluate it here. So that won't work because it expects arguments, right? It expects the 2 positional arguments, 1 and 2. And this is a keyword argument, so it's not expecting that as per se, although I didn't define here a default value, right? You see that. This won't work because 3 is given as a positional argument without its name. This will work because it's 2 positional arguments and 1 keyword. This will work as well because we specify the second argument with its name, but that falls here between the slash and the star. So that works as well. And lastly here, that will not work because we provide the name of the argument for the first one, and that's supposed to be only positional. So that's what I wanted to show you here. Frankly, I didn't use it so far in practice. Maybe after I know it now, I will find the use cases. Leave some comments below. How do you use this in your code? I hope you found it interesting and useful. Let me know in the comments. Don't forget to click the like button and subscribe to the channel if you liked it. I'm Dr. Dror. Thank you for joining me and see you in the next videos.